Today I'd like to go over some of the basics of chemistry. This here is the handy-dandy periodic table on which you can find all the known elements and their stats. These are often represented like this. This number is A, or the mass number. It corresponds to the combined number of protons and neutrons within the atom's nucleus. And this is the atomic number, or Z. This is the number of protons in an atom, or the number of electrons. They're usually the same. If the number of protons changes, a whole new element is formed. If the number of neutrons changes, it becomes a different isotope of the same element. If the number of electrons changes, the atom is either a cation or an anion. An atom's mass number is in atomic mass units, or AMU. When atoms combine into molecules, you can measure molecular weight by adding together the weights of the individual atoms. When atoms combine or split up, it is represented by a chemical equation, like this one. To balance it, you adjust the numbers in front of the molecules to make sure every atom is accounted for. The process is just like in math. Both sides of the equation have to be equal, since mass cannot be created or destroyed. Now comes the real fun, stoichiometry, the method through which we can convert atoms to moles to grams and back again. Side note, a mole is equal to 6.022 times 10 to the 23rd of something, in this case, atoms. And conveniently, 1 mole of an element weighs as many grams as a single atom of that element weighs in AMU. So say we want to know how many kilograms of carbon dioxide are formed when 12 kilograms of octane are burned. The equation for that reaction, when balanced, looks like this. We start with 12 kilograms of octane, which is equal to 1,000 grams, and 1 mole of octane, with 8 carbons and 18 hydrogens combined, weighs a total of 114.232 grams. So we line all of these numbers up so that the units cancel out until we're left with 105 moles of octane. So 105 moles are reacting, and the equation tells us that every 2 moles of octane can produce 16 moles of carbon dioxide. So after the reaction, we'll be left with 840 moles of carbon dioxide. Finally, we know, by combining the weights of 1 carbon and 2 oxygens, that 1 mole of carbon dioxide weighs 44.009 grams, so we can convert to find the answer of 37 kilograms of carbon dioxide.